Welcome back. This tutorial is going to talk about some of the basic gears. I'm Mr. Michael, and let's get started. So to get started off, we're going to start off one of our smaller gear, and this will be a 8-tooth gear because it has 8 teeth or 8 wedges, and it has a space in the middle for a axle to go through. Axle through, you can see it flows through this one well, and as the axle turns, the teeth mesh with another gear and it turns it. As you can see, it's turning the opposite direction as gears do. Look for our gear video talking about how gears move. This is basically talking about the name and introduction and getting you to meet these gears if you haven't met them already. So this yellow one is not a particular color that comes out. Some of the specialty sets, but yellow is one of my favorite colors, so I try to introduce and use one of the yellow elements if I have it. The gray, darker gray, will be one of the education and now using more retail sets. And you have one of these newer, I can get this one locked in. See these extra grooves? These extra grooves kind of, see if that's showing up. It looks a little more dense, a little bit fuller on it. Hope that's showing up on the video. There it is right there, yes. Good shot, good job, Mr. Michael. There it is right there. See how those grooves come all the way to the end there? I'll talk about that, why those are used here in just a second. So we can get one lined up here, and I'll get one of our Technic bricks out, and I will get let's get a 24-tooth gear. By the way, this is a 24-tooth gear. Okay, so in our model, when one gear is turning, we have an 8-tooth, and this gets into your fun math facts here. 24-tooth and 8-tooth, we talk about ratio. If a 24-tooth turns an 8-tooth gear, what's the ratio? This is a 1-to-3 ratio because it takes 3 8s to go into 24. 1 turning, 1 rotation, fully turning, 3 rotations, or a 3-to-1 ratio, gearing up, gearing down, torque, different things like that. So when these are turning, sometimes the pressure will be so hard, so tight, so much torque, till I've noticed, should have brought out some of my older gray, lighter gray, you see that it look like the teeth when they're meshing in there, it would actually separate and it would spin over, it would click, it would push so much pressure on that gear, it would actually click and bend and rub the teeth all the way down. Well, as I'll brag on Lego a lot here, they came up with this newer gear, which has a lot more connectability, a lot more surface area. And if this gear starts looking for ways to exit its force by leaning in or up or out, it would actually grab and mesh a little bit better, which does not allow it to escape as much. So this gear is really cool. It still has that like small wiggle in there, but the teeth mesh in a whole lot better at most angles, and it actually works a lot better with the double bevel or conical gear as well, which are that'll be in a different video, the double bevel conical gear. So let's get this back out here, put these number 8s down, and yes, you do see a red. I thought we were done with all of the 8 gear. If you haven't used one of these, I haven't used these in a lot of models, but I want to take the time to use this. Number 8 is 8-tooth, not number 8. It's an 8-tooth gear. This actually is a frictionless. Look at that guy right there. Is that amazing? The other ones do have friction that would stay in place, and they would allow your machine to stay focused if you don't have it wedged between a beam or a brick of some sort or another gear. But this one actually flows back and forth, and I'm really excited to get creative with this gear. I don't have a model that, actually I think I do have a model that this is in. But anyway, this one is out there, and I only know of it being in red so far, but it does flow really well, and it's still strong, and it has those extra, there you are, extra groove elements in there as well, so you can do some fun things with them, maybe in your shifter, maybe clutching, maybe forcing, oops, sorry about that, left you in bad focus, maybe shifting it, sliding it back and forth with a clutch, with a pivot clutch area, and that's another, to move that gear around for different slots and maybe gearing things up or down. So that's a fun one. Please look out for video on that. I want to get that going and put that in the lineup of gears as well. So I know I got to get it back in line. This guy, let's put this guy back up here. So 8-tooth gear, and then we get into our 16-tooth gear. So let's talk about the differences in these two elements. So you can see this one here is a newer, by the way, this one's a newer 16-tooth, and this is a older 16, and you can see how they, I guess you can call that a diamond shape in the middle, and this one is more open. There are a few, there are a few reasons I found that this works well on. So let's get you can use this in a regular Technic piece here. So this groove, this cross area actually works inside of a plate. Now I'll use it better in a Technic plate, and these grooves just lines up in there really well. You can use an axle here, put a stopper here. Now you have this guy moving around, a little wobbly. It's got a little play in there, but you can use it to actually transfer energy if you didn't know. And this newer one actually locks in a lot better. So much so, it actually clicks in and just stays in, where this one does not. Put them side by side, and now it stays because it's locked in somebody else. Oh, there it goes. So it doesn't stay, it doesn't lock in. It's not milled or pressed to lock in as well, but that one stays in really well. Hence a tighter turn, hence a tighter push, hence you won't have to add anything to the back of it to allow it to continue that force. You can make it flush there and just get your motion going. I would say get your groove going there, but that's different. Anyway, another reason why I feel that this one was produced is the same reason for this 24-tooth gear, which is like, what is that? We'll talk about that in a little bit. Is when you're using this for force, you're applying a great amount of force. I'll get one of my angled beams here. Yes. You'll notice that I get the same color, and I like to use opposing colors so you can see what's going on. When I'm using this as force, focus here. When I'm using this as force, you can see I'm twisting. See if I can get this going. I'm twisting this gear. Yes, wearing my fingers out. These are called teeth, by the way. These wedges are called teeth, so you kind of see why. I'm twisting this, and after a while, these little parts in here will pop out. I haven't had any, I don't use this gear as much, the 16-tooth gear as much as I use a 24-tooth gear, but that looks like it would pop out. So I haven't forced any of these to break in any of my models, but this, I can see where that would work. Now you can see the more rigid surface area connector, everything's closed, and this one is not closed. That would be one of the reasons I would see where Lego would have created that focus, that part. Here on the 24-tooth crown gear, probably should have done a separate video on this. Sorry for it being so long, but I did want to cover these basic gears. We have probably 6 more different videos on other gears coming soon. So it's a crown gear. Crown gear has this little curve, and I always tell the students, this looks like a crown on your head, so you can remember it's called a crown gear. And these teeth allow it to work okay as a spur gear. Okay as a spur gear, but really well as a crown turning a 90-degree angle. So this would grip in and turn this at another angle. You can, this is where you get your helicopter propeller or turning an opposite angle element in there. They don't work as well together because you see the teeth in there really, really light. You can see I have 2 different styles. This one on the left here is an older, and you don't see the support that the newer one has with the rigid shapes and the triangle areas in there. And again, if you applied enough force, you could break a few of these. You could break them out, and you could lose pressure in there. So if you're really trying to get something to move, you could get this to go almost a 1/10 of turning, maybe 20%. You can get 20% turn in there before, yeah, it's wearing me out. 20% turn in that flex space without the model even moving, if you're gearing something down well. On the other hand, I'd have to do a real full test. This one here is a lot stronger, and maybe a 10% turn in there before I really have to really force it, and that will be a problem with the machine. You need to go in the machine and figure out the friction stoppage inside of that. Okay, that's the first 3 lines. I have 2 more lines to go to, and this is your basic 24-tooth spur gear with a lighter retail and the darker gray for education part, and these may be familiar. This one is an older one. It's not in circulation anymore, well, not being produced anymore. And what this gear, this 24-tooth gear allows you to do is add, I was going to do this well, is add the axle in the middle, of course. Add the axle in the middle, but also you can add an axle in the top portion here. Isn't that awesome? And another axle into the bottom portion. So why would you use that, Mr. Michael? I am glad you asked. If you are doing and he didn't bring another one. If you're going to make a cam set, you could have the middle one turning, and then you can do this well. You can have one middle one turning and this going up and down, up and down. You can have it going there and put another one on the other side. Have really cool cam set going with these elements and make a lot of different models in that. But what was happening when you give it a lot of pressure, it was breaking these middle pieces out a lot. Like they were really, really fragile. And when I first got Technic at the beginning, I actually started off in the beginning of where Technic was 42 years ago. These were really breaking off a lot, and I was like, my models are breaking, and so it was really disappointing that you have your gears breaking and you had to order more. And back then you'd have to mail in an order form and then wait for it to come in and then get it. It wasn't like within a week, it was 3 to 4 weeks shipping, COD and things like that. So some of you guys are laughing. Yes, it's funny now. But anyway, let's get into the 40-tooth gear before I get in a 30-minute video here. So 40-tooth gear, and as you notice, they did keep these outer opportunities for you to put an axle in. So you have 1, 2, 3, 4, 5 opportunities to put an axle in, and you can still do that cam effort. The 24 gear, which I didn't talk about, you can actually put that piece in the newer ones, and it's a frictionless circle or a Then you can put connectors in there to move around, transfer energy and such in different ways. So there's still a lot of opportunity with the 24 tooth gear. Just that middle part is not used anymore. I have these 240 tooth gear here because I want some color variation, but also just show you that there's a lot of really cool colors out there. And you have a yellow in the 24 tooth gear. With the 40 tooth gear, 40 teeth going around, and you would just stop and count how many teeth these are, and these will mesh really well. I really like, this is one of my favorite gear elements, the larger, because they were really hard to come by when I first started building, and I only had one, maybe two forever. And I like it because you can make things go faster, gear things up faster, so you would have more horsepower here. 40 tooth turning an 8 tooth, and you guys know what that rotate ratio is. Anybody? Yes, 5. So it takes 8. It takes 5 eighths to go into 40, which will make it one rotation, pushing out 5 times faster. 5 times faster on some of your models will really get some things rolling. You get compound gears going in, which would be on the actual axle tension force. Okay, getting too deep into conversation. So 40 tooth gear is a lot of fun. And you have these 2, 4, 6, 8, 10, 12 open holes over here that you can use a little opportunity as well. So all of these gears go with the crown gear well. 40 tooth goes with the crown gear well. 24 tooth goes with the crown gear well. 24 tooth crown to crown does okay. 24 tooth with the 16 gear does well. And now you say, does it work? Well, yes and no. So the challenge with the crown gear with the 8 tooth gear is you really don't have a lot of space to get your axle down and over. But with the newer, you can actually slide that over and just get it inside of that. I wouldn't recommend using a crown gear with a 8 tooth gear. You have other opportunities to transfer energy in. And that will be in some of our next video or other video on double bevel conical gears, which go all kind of opportunities of angles, almost, I wouldn't say limitless, but a lot of opportunities. So thank you so much for this welcoming to the basic gear. We have a lot of other gear video to explain the names, and then we'll put some of these guys to use. I spoke of gearing up and down. There's some models out that talk about usage of these gears, and then pulley belts and such. And then we'll even get into some of these really interesting turntable, how to transfer energy from the top to the bottom. So there's a gear inside of here. So please look forward, subscribe, and keep up with the journey that we're going on. And please send comments in. I would love to hear your questions, comments, or concerns about any of the gear, model, beam, brick elements we may have out there. Thank you guys. Mr. Michael, over and out.